This is my dream university, you see?
Yeah, me too.
I'm sorry. I need a minute.
It wasn't working well anyway.
No, maybe you go to get repaired and then I'll pay you back the cost.
No, you don't need to.
No, I'm sorry. Do you have any papers on you?
Papers? Yes.
Oh, thanks.
I can find your pen.
Why can't Jane write her phone number on the food receipt without using pencil? Actually, she's writing on a special type of paper, thermal paper. The thermal paper secret of printing is based on acid-base chemistry. The thermal paper is coated with a layer of chemical dye which is sensitive to the pH. On the bottom, there's another layer of acidic material which is sensitive to the heat. When heated, the bottom layer that contains acid, for example octodecylphosphoric acid, will melt and in turn release protons to change the environment to be acidic. In acidic conditions, chemical dyes such as crystal violet lactone can accept a proton and transform from a colorless state to the black color. So, to print out on a piece of thermal paper, all we need is just heat. When Jane scratched the food receipt using her fingernails, the heat generated from friction allows her to print on the paper. Since the thermal paper was first introduced in the 1960s, it has been widely used all over the world. Even on our campus, we can find a number of examples such as LG7 canteen, ATM machine, park and shop, and the bookstore. Thermal paper is a great example of the application of acid-base chemistry in our daily life.
Hey Jane, is right here the new trend? You have so many of them.
Really? Oh my gosh! I just stayed up all night to complete 2 assignments. This is so sad.
Gloves. Comb. Hair dye.
Dr. Wei, can we start?
So how does hair coloring work? Its mechanism is actually based on redox chemical reactions. To understand the principle of the hair coloring, let's first take a look at the structure of our hair. Our hair consists of 3 layers: medulla, cortex, and cuticle. Medulla is a dense fiber and forms the core. Cortex is a middle layer and contains hair pigment that gives the color of our hair. The outer layer is thin and transparent. There exist 2 types of pigment in the cortex, eumelanin and pheomelanin. Both of them are large organic molecules. Eumelanin gives black or brown color, while pheomelanin gives yellow or red color. The ratio of these two pigments determines the color of our natural hair. For example, Asian people have black hair because we have a lot of the melanin in our hair cortex. To add a new color to our hair, we normally need to first remove our natural hair pigments. This process is called hair bleaching and often achieved by adding to oxidizing agents such as hydrogen peroxide. Hair pigments will be destructed through oxidation reactions to produce carboxylic acid from alcohol. Now, we can choose from different types of dye molecules and make them bend to our hair to give it a new color. So if you accidentally dye your hair in a wrong color like June, don't worry. All you need to do is run the hair coloring process again, using a dye with a different color.
I'm doing all of this only because I've got an interview tomorrow. What's up with you? Don't give me this look. How maybe I can be your pretty girlfriend? Look at your teacher, excuse me back. What? Is it clean?
Yeah, it's clean. Wait. It's strong.
Yes. Let me stretch it out for you.
Let me help you.
It's really small.
So, why do cotton garments often shrink by a size or two after washing or drying under heat? The answer is related to the intermolecular interactions among cotton fiber molecules. Cotton fibers are made up of a naturally occurring polymer known as cellulose. The chemical structure of cellulose looks like a long molecular chain constructed by linking many sugar molecules together. Several thousands of sugar units may be found in a typical cellulose molecule. The OH groups along the cellulose chain are polar and can interact with each other through hydrogen bonding. Hydrogen bond can form between OH groups on different chains to form crosslinks, and this is a form of intermolecular interaction. Because of these hydrogen bonds, the cellulose chains in their natural state are tangled together and crinkled. We will call this the relaxed state. When cotton fibers are spun into threads to be woven into a soft fabric, the pulling and tension will break the existing hydrogen bonds and at the same time straighten and stretch out the cellulose chains. New hydrogen bonds would then form to lock up the cellulopolymers in this new state, which we will call the stressed state. Of course, the polymers will want to return to their original relaxed state. So, when you wash or dry a cotton t-shirt under high temperature, the heat and tumbling action will provide energy to break the hydrogen bonds, allowing the polymers to return to their curl-up relaxed state. Therefore, the cotton fibers shrink to their original pre-stretched size. A useful tip would be to wash your cotton t-shirt in cold water and avoid the dryer by letting it air dry.